Hello everyone, welcome to Epsilon Pro Academy. In our previous studies, we talked about a function where y was clearly expressed in terms of x, such as what we have here. And this is what we call an explicit function because the independent variable x was completely isolated. However, not all equations are written in this form. Sometimes x and y are mixed up together in the same equation, making it impossible or very difficult to express y directly as a function of x. Example is what we have here. And this is what we call an implicit function. So by definition, an explicit function is a function where the dependent variable y is not expressed explicitly in terms of the independent variable x. Now let us consider some of the examples of an implicit function in mathematics. So let's consider this example number 1 on the board. The question is x squared plus y squared plus 6x minus 2y plus 4 is equal to 0. Now this is an implicit function. We observe that x and y variables are mixed up in the expression on the board, in the equation on the board rather. So we are going to differentiate each of the respective terms with respect to their variables. But before we can differentiate this, let us recall the derivation formula. In the derivation formula, if y is a function of x or given as ax raised to the power of n, we know that dy over dx will give us this power times the coefficient, that is a and x, then subtract 1 from the power n minus 1. Let's note this first. Now we are going to apply this formula to each of the respective terms on the board. On the board we have x, y, x, y. So to differentiate the first term, we have applying this formula to this, so it will become 2 times 1, which is 2, then subtract 1 from it. So we have 2x plus, now since we are differentiating y term, we are going to attach the y over the x to it. That's how to distinguish between this and this. So that will give 2y then times dy over dx. Then over to x term plus, if you differentiate 6x, we have 6 using this formula. Again, minus 2y, if you differentiate 2y, it becomes minus 2. Now the concept is that when differentiating for y, we attach dy over dx to it. So the derivation of a constant term is always equal to 0. So plus 0, this is equal to 0. Now let's bring the derivation of the x together. So that will become this 2x plus 6 plus 6 plus that of y together. So we have 2y minus 2, then dy over dx, and this is equal to 0. Now we observe that this is the derivation from the x terms, while this person is the derivation from the y terms. So let us move this person over to the right hand side. 2y minus 2 dy over dx is equal to, when you move this person over to the right, to become minus, so minus 2x plus 6. Now the question is determine dy over dx. To find dy over dx, we divide both sides of the equation by the coefficient of dy over dx. So the coefficient is 2y minus 2. 2y minus 2. So this cancels this. We are going to be left with dy over dx. And dy over dx will equal to minus, if you factorize this, we have 2 in bracket x plus 3, all divided by, if you factorize the denominator, we have 2 in bracket y minus 1. So this and this goes to work, and dy over dx will equal to minus x plus 3 over y minus 1. And this becomes its final solution. That is how simple it is. Now let's consider this second example on the board. This is quite different from the previous example we did. So in the question on the board, we have x squared plus 2xy plus 3y squared is equal to 4. Now, let's record the general formula for derivation, that if y is equal to ax raised to the power of n, then dy over dx should be anx raised to the power of n minus 1. Don't forget this formula. Now, the first thing we have to do, let me rewrite what we have here. X squared plus 2xy plus 3y squared is equal to 4. Now, we are going to find the derivation of each of the respective terms on the board. Derivation of x, derivation of this x and y, derivation of y, and that of constant term. But in this case, the first thing we have to do is to move the constant term over to the left and equate it to 0. So that becomes x squared plus 2xy plus 3y squared. When 4 crosses over, minus 4 is equal to 0. Now the next is to find the derivation of each of the respective terms using this general derivation formula. Now note that whenever you are looking for the derivation of y term on the board, always attach dy over dx to it. So let's start with the first term on the board. This is for x. The derivation of this becomes 2x. Then plus, this is a different case compared to what we have done so far. In this case, we have both x and y mixed up in the same term. Now, whenever you are coming across a term that has both x and y in it, such as this, we are meant to differentiate twice. That means we are going to differentiate with respect to x, then disregard the y, and also with respect to y and disregard the x. So this is how it works. When differentiating for x, assuming that y does not exist. So if I cover this person, what are we going to observe? We observe that it's only 2x that will be seen. And the derivation of 2x gives what? 2. So I'll write my 2 here. Then times y times y. Then plus. So assuming that x doesn't exist, if I cover this x, only 2 and y will be visible. So what is the derivation of what is visible? The derivation of this and this gives you what? 2. So we have 2. Then multiply this by the hidden variable, which is x. So because we are finding the derivation of the y term, always ensure that you attach dy over dx to it. The concept is very simple. When differentiating for y, ensure that you add dy over dx to it. So that becomes times the y over the x. We differentiated this person 2 times, 1, 2. So the next is this. And this is to differentiate y terms. So that becomes plus, to differentiate this, multiply this by this, which equals 6y. Then attach dy over dx to it. dy over dx minus the derivation of a constant term is equal to 0. So 4 gives 0, and this is equal to 0. So this gives 2x plus 2y plus 2x dy dx plus 6y dy dx is equal to 0. Now let us group the derivation of x and y terms in brackets. So this is for x, this is for x, this is for y, this is for y. So we have for x, 2x plus 2y plus is equal to 0. Next approach is to move this person over to the right hand side. So that becomes this person 2x plus 6y dy over dx will equal to, when this person crosses over, so we are going to obtain minus 2x plus 2y. So now is to divide the two sides by the coefficient of dy over dx, because we are meant to make dy over dx the subject of the formula. So dividing the two sides by 2x plus 6y, 2x plus 6y, and that will give this, and this will go to work. So dy over dx will equal to minus, let's factorize what we have here. So we have 2 outside the bracket, x plus y, divided by, let's factorize what we have here also. So we have 2 outside the bracket, x plus 3y. So 2 and 2 goes to work, and we are left with dy over dx is equal to minus x plus y divided by x plus 3y. So that is the final solution for this. Implicit function is very simple. If this video was helpful to you, click on the like button and also share this video. Let's consider this example on the board. This is quite different from the preceding example that was solved. The question is 4y squared x minus 5x squared y cubed plus 4y is equal to 10. The first thing we have to do is to bring the constant term over to the left hand side, then equate it to 0. So we have 4y squared x minus 5x squared y cubed plus 4y is equal to, minus 10 is equal to 0. Now the next approach is to find the derivation of each of the respective terms on the board. Now the concept is very simple. If there is a term with the two different variables present we must differentiate that term twice, with respect to x and also with respect to y. And also, when differentiating that term, we are going to consider one of the term as an invisible term. And after the derivation, we multiply the result by that invisible term. So if I'm differentiating y variable, I will consider this person invisible. What we are seeing right now is 4y raised to the power of 2. But if I'm differentiating x, I'm going to cover this person, consider this person invisible. And what you will be seeing is 4x. That is the simple concept about this implicit function. So let's do that. To find the derivation of this y variable, so it will become, I'm going to hide this person, and what is present here is 4y raised to the power of 2. And what is the derivation for 4y raised to the power of 2, which gives me 8. Then subtract 1 from the power, that is 8y. So we have 8y, then multiply by this invisible term, x. Because we are differentiating y variable, always ensure that you add dy over dx to 8. Then plus, we are differentiating this term 2 times. We have done that in terms of y, so we are going to do it again in terms of x. So now we are differentiating in terms of x. This person will be invisible. So the only terms seen is 4x. And if you differentiate 4x, you obtain 4. Then multiply this result by this invisible term, which is y squared. Then over to the next term, minus, we are differentiating in terms of x. If I'm differentiating in terms of x, I'm going to cover this person. And the only terms that will be visible will be 5x squared. So the derivation of 5x squared becomes 2 times 5, which gives me 10. Then subtract 1 from the power, which is x. Multiply this result by this person, the invisible term, which is times y cubed. Because this term comprises of 2 variables, x and y, I'm going to differentiate again. It must be 2 times. I'm going to differentiate again in terms of y. And if I'm differentiating in terms of y, then this person should be invisible. If this person is covered, then we are going to be seeing 5 and y cubed. And the derivation of 5y cubed will give us 5 times 3 times 5 rather, which is minus 15. I'm using minus because there's a minus sign here. Minus 15, subtract 1 from the power, y raised to the power of 2. Then multiply by the invisible term, x squared. Then the concept is that when differentiating for y, always ensure that you add dy over dx to it. Dy over dx. Then plus 4. To differentiate 4y, it will give you 4. 4, because we are differentiating the y variable, so that will become dy over dx. To differentiate the constant term, 10, it will give you 0. So this is equal to 0. That is the simple logic. So now let us rearrange them. We have 8xy dy over dx plus 4y squared minus 10xy cubed minus 15x before y, then dy over dx plus 4 dy over dx is equal to 0. Now let's put the derivation of the x terms in one bracket and also the derivation of y terms in another bracket. So from y we have, this is y term 1, y term 2 and y term 3. So it will become in bracket 8xy minus 15 minus 15x squared y squared plus 4 plus 4 then dy over dx. Then let's do the same to x terms, and this is x terms. This is x terms 1, 2. So we have just 1, 2. That is plus bracket open 4y squared minus 10x squared y squared equal to 0. This is equal to 0. Now the next approach is to move the x terms to the right hand side. So that will become 8xy minus 15x squared y squared plus 4 dy over dx is equal to, when this person crosses over, it becomes minus 4y squared minus 10x y squared. Now we have to divide the two sides by the coefficient of dy over dx. So which is 8xy minus 15x squared y squared plus 4 8xy minus 15x y squared plus 4. Then this would cancel this, and we are going to be left with dy over dx over dx is equal to minus 4y squared plus 10xy squared, all divided by 8xy minus 15x squared y squared plus 4. And this becomes the final result. If this video was helpful to you, click on the like button, share this video so it will get to others, and also subscribe if you haven't subscribed. In our next video, we are going to consider parametric equation and also application of differential calculus.